Welcome to Math Club. Today we're talking about trigonometry. This is part 1. Okay, so if I have a right angle triangle, right here is our angle theta. It's a Greek letter, just an O with a line through it. So let's go ahead and look at the side, this side length. What is this relative to our angle theta? Well, it's kind of opposite to it. It's the side facing it. It's the side opposite. Because it's completely opposite from the angle. Okay? What about this side length? Well, it's kind of right next to it or adjacent to it. It's right next to it. So it's adjacent. Right? Because if I have like two lines, this right here, this angle, and this angle, that angle are going to be adjacent because they're right next to each other. So this is adjacent to this angle because it's right next to it. This right here is the hypotenuse. Right? It's the hypotenuse of the right angle triangle. So what would this be? Well, this is called the sine. The sine of theta. This is how you'd write it out. This is how you say it. Sine of theta. It's not sine times theta. It's sine of theta. It's a function like f of x. Like f of x. Right? Or x like that. Right? So, sine of theta is going to be opposite over the hypotenuse. Opposite of your angle. It's all relative to your angle, okay? Cosine of your angle theta is going to be the adjacent side, the side right next to it, over the hypotenuse. The adjacent over the hypotenuse, okay? And your tangent of theta is going to be, well, your opposite over your adjacent, okay? Okay, so now, what about this is importance? So, say we have a 3 by 4 by 5 right angle triangle. Right here is our angle theta, and we want to figure that out. Well, what are the ratios? Well, the sine of theta is going to be the opposite, which is 4, over the hypotenuse, which is 5. Cosine of theta is then going to be the adjacent, 3 over 5. The tangent of theta is then going to be the opposite over the adjacent. So 4 over 3. Now, looking at all this, what does any of it mean? What is theta then? We don't know. Well, as long as we know the ratios, we know the angle. So if I have a 3 by 4 by 5 right angle triangle, and I scale it up to a 6 by 8 by 10 right angle triangle, this angle right here is still theta if this is theta right down here. And the ratios of sine, cosine, and tangent are still the same because 8 on 6 can be simplified to 4 on 3. 8 on 10 can be simplified to 4 on 5, and 6 on 10 can be simplified to 3 on 5. So, because it's consistent with the angle, and the ratios are all consistent, we can imagine that there's an inverse function, like f inverse of x. Now, you might not know what this means. It basically means if f of x gives you y, okay, some function of x gives you y, then f inverse of y gives you x. So, as an example, say y is equal to x, okay? Or rather, f of x is equal to x, right? So we can say that f inverse of x is also equal to x. Pretty simple. This is because if I input x into this, I get the original. So, in other words, if I do, basically what inverse functions do is they cancel out your original function. That's the idea. It cancels out your original function. This returns then x because it's applying the inverse to your original function. So basically meaning f of x equals y, meaning f of y is x, right? F inverse of y. Because f of x is y, that means f inverse of f of x gives you x. And okay? So, meaning we know that the tangent of theta is 4/3, right? Instead of writing it like this, let's write it as the tangent inverse, apply it to both sides. The inverse that cancels out your tangent, your original tangent. Okay? So now, if I go ahead and see what this gets me, well, these kind of cancel each other out. They just give me my theta, right? Theta is the tangent inverse of 4 on 3. Well, you need a calculator to do this, okay? Now, so let's get out a calculator. So here, it's a nice pink calculator. Now, let's turn it on. Let's hit second. Hit the tangent button, the TAN. Right? Now, let's apply this on 4/3. Okay? Hit enter, and we get 0.927. You're like, that can't be right. Well, it's because I'm in a different thing. I have it on the wrong setting. I have to change this to degrees, so make sure that yours for right now is on degrees. Next episode, it won't be on degrees, but right now, make sure it's on degrees. So change this to degrees, and now do the same thing. It's going to be right around 53.13 degrees, meaning theta, marker ran out. So in other words, theta is approximately equal to 53.13 degrees. Next episode, we'll go into radians, which is the correct units. Degrees are kind of like a middleman. So now you know how to find angles on this. The other one would just be 90 minus our theta, right? Because this is a right angle triangle. So, yep, there you go.